Could Tesla be about to change the electric vehicle industry once again? Tesla has already transformed the way the world thinks about electric cars, but now a new motor technology is raising an even bigger question. Has Tesla found another way to make EVs more efficient, powerful, and affordable? The technology is attracting serious attention across the automotive industry, with major companies like Toyota, BYD, and others closely watching Tesla's next move. But what exactly is different about this new motor? Is it simply an improved electric motor, or could it represent a major shift in how future EVs are designed and built? And if Tesla really has found a breakthrough, why could this technology force some of the world's biggest automakers to rethink their entire strategy? Before we uncover what Tesla has developed and why it could matter so much, make sure to subscribe to the channel and turn on notifications so you don't miss more fascinating technology and automotive stories like this. Before we understand what Tesla's latest motor technology could mean for the future, we need to take a step back and look at how this company became one of the biggest names in the electric vehicle industry. Tesla's journey sounds almost like a movie. In the beginning, very few people believed electric cars could seriously compete with traditional petrol and diesel vehicles. While critics were laughing at the idea, a small group of people believed that electric transportation could eventually change the entire automobile industry. The story began in 2003, when two Silicon Valley engineers, Martin Eberhard and Mark Tarpenning, decided to pursue an ambitious idea. They believed the growing dependence on petrol and diesel vehicles was contributing to pollution, and they wanted to prove that an electric car could be more than just an environmentally friendly alternative. It could also be fast, powerful, practical, and capable of traveling a meaningful distance on a single charge. That vision led to the creation of Tesla Motors. The company was named after Nikola Tesla, the famous inventor and electrical pioneer whose work helped shape modern electrical technology. At the time, Tesla had nothing close to the massive production facilities or financial resources it has today. There was no global charging network, no millions of cars on the road, and certainly no guarantee that the company would survive. There was simply an idea and the determination to make it work. Then, in 2004, Elon Musk entered the picture. Musk had already made a fortune through PayPal and was simultaneously building SpaceX. After becoming interested in Tesla's mission, he invested roughly $6.5 million into the company and became its chairman. Although Eberhard and Tarpenning were the original founders, Musk's enormous financial contribution and his long-term vision eventually made him one of the central figures in Tesla's story, and later led to his recognition as a co-founder. But Tesla's early years were anything but easy. In 2008, the company released its first production vehicle, the Tesla Roadster. It was an electric sports car capable of accelerating from 0 to 100 kilometers per hour in less than 4 seconds and traveling more than 300 kilometers on a single charge. For an electric vehicle at that time, those numbers were remarkable. But many people still refused to take Tesla seriously. Critics argued that electric cars could never travel far enough, that their batteries would run out too quickly, and that EVs were little more than expensive toys. Some media outlets and industry experts questioned whether Tesla could survive at all. To them, Elon Musk appeared to be taking an enormous financial risk on an idea that had little chance of becoming mainstream. Then came another major problem. The global financial crisis of 2008 put enormous pressure on Tesla. The company was running dangerously close to failure. With the future of the business hanging in the balance, Musk put more of his own money into Tesla and sought help from people around him to keep the company alive. Eventually, he took over as CEO, while the company went through painful restructuring and layoffs. For many businesses, that could have been the end. For Tesla, it became a turning point. The company continued pushing forward, and in 2012, Tesla introduced the Model S. That vehicle changed the public perception of electric cars in a major way. Suddenly, an EV was no longer seen simply as a slow, limited car designed only for environmental reasons. The Model S showed that an electric vehicle could also be luxurious, powerful, technologically advanced, and exciting to drive. Then came the Model X, followed by the Model 3 and Model Y. The Model 3 was particularly important because it brought Tesla closer to the mass market. People who once doubted the company were now seriously considering buying its vehicles. Musk's broader strategy was also becoming clear. Start with an expensive performance vehicle, use that technology and revenue to develop more affordable models, and eventually create electric cars that could reach a much larger audience. Tesla also invested heavily in its supercharger network, helping address one of the biggest concerns surrounding electric vehicles: where and how drivers would recharge them. And Tesla introduced another idea that was unusual for traditional automakers. The vehicle could continue improving through software updates even after it had left the factory. At the time, this approach was radically different from the way most automobile companies operated. Fast forward to today, and Tesla has become one of the world's largest electric vehicle manufacturers. The company delivered roughly 1.8 million vehicles in 2023. Deliveries then declined slightly to around 1.79 million in 2024, followed by approximately 1.636 million in 2025. But 2026 has shown some signs of recovery. During the first half of the year, Tesla reportedly passed 838,000 vehicle deliveries, including roughly 480,000 deliveries during the second quarter. In July 2026, Tesla also announced that its cumulative vehicle production had reached 10 million units. So despite the fluctuations from year to year, Tesla remains a company producing roughly 1.6 to 1.8 million vehicles annually. But the EV landscape has changed dramatically since Tesla first entered the market. Tesla once appeared to have a huge lead over its competitors. Today, however, competition has become far more intense. One company in particular has emerged as a major challenger: China's BYD. In 2025, BYD sold more than 2.2 million battery electric vehicles, exceeding Tesla's total for the year. Tesla's share of the global battery electric vehicle market is now generally estimated to be somewhere between 8% and 12%. And the pressure is especially strong in markets such as China and Europe, where manufacturers are introducing increasingly affordable electric vehicles and competing aggressively on price, technology, range, and efficiency. In other words, Tesla is no longer operating in a market where it can simply rely on being the company that made EVs popular. The competition has caught up. And that brings us to the real question. If Tesla wants to regain an advantage, what can it do next? One possibility could be hidden inside the very component that sits at the heart of every electric vehicle: the motor. And this is where Tesla's latest motor technology becomes especially interesting. Tesla continues to maintain a powerful presence in the United States, but its success cannot be measured by vehicle sales alone. The real strength of Tesla comes from the ecosystem it has built around its cars. Its brand, software, full self-driving technology, energy storage business, battery development, and massive gigafactories all play an important role in the company's identity. And Tesla is no longer focused only on electric vehicles. The company is also working on ambitious projects such as robotaxis and humanoid robots. That is one of the reasons Tesla is increasingly viewed as something more than an automobile manufacturer. Many people now consider it a technology company that happens to build cars. But perhaps the biggest lesson from Elon Musk's Tesla journey is much simpler. When everyone around you says your idea will fail, walking away may be easy. But continuing to believe in your vision can completely change the outcome. Musk took enormous risks. He invested his own money, faced repeated financial problems, dealt with intense criticism, and came dangerously close to watching Tesla collapse. Yet, he continued moving forward, and eventually, Tesla changed the direction of the automobile industry. Companies such as Ford, GM, and Volkswagen began investing much more aggressively in electric vehicles because Tesla demonstrated that there was a genuine market for them. Tesla also helped accelerate battery development, expand charging infrastructure, and push electric vehicles into mainstream conversations around the world. Of course, the situation is very different today. Competition has become much tougher. But Tesla's technology, brand recognition, manufacturing capabilities, and reputation for innovation remain powerful advantages. And that is exactly why Tesla is once again attracting so much attention. The company is preparing to make a significant change to the electric motors used in its vehicles. What makes this particularly interesting is that the technology is not expected to remain exclusive to expensive or high-performance vehicles. It could eventually make its way into mass-market models such as the Model 3 and Model Y. And this isn't simply about making a Tesla accelerate faster. The bigger goal is to create motors that are more efficient, lighter, more compact, and potentially cheaper to manufacture. But why does Tesla even need a new motor when modern electric motors are already so advanced? The answer comes down to several important challenges. The first is efficiency. An electric motor does not convert every bit of electrical energy from the battery into motion. Some of that energy is lost, primarily in the form of heat. The more energy that is wasted, the less energy remains available to move the vehicle. That means improving motor efficiency can directly contribute to better range and lower energy consumption. Then there is the problem of heat. When an EV is driven aggressively, climbs steep roads, travels at high speed, or operates under heavy load, the motor can become extremely hot. Once temperatures rise too far, the vehicle may need to reduce motor output to protect the system. That can ultimately affect performance. There is another challenge that has become increasingly important: rare earth materials. Many electric motors rely on powerful permanent magnets made using rare earth elements. The global supply of these materials is concentrated in a relatively small number of countries. That creates a potential problem. If supplies become limited, prices rise, or geopolitical disruptions affect the market, the cost of manufacturing electric motors could increase significantly. Because of this, automakers around the world are searching for ways to reduce their dependence on these materials, or use them much more efficiently. So, what exactly is Tesla changing? Reports surrounding Tesla's next-generation motor technology suggest that the company is working toward a more powerful and efficient design that could potentially deliver around 50 additional horsepower. If that happens, drivers could notice a stronger and more immediate response when pressing the accelerator. But the most interesting part of the design may not be the extra power at all. It is the rotating component inside the motor. Tesla is reportedly using a high-strength carbon fiber layer around the rotor. Why does that matter? Because the carbon fiber reinforcement can help the rotating assembly withstand extremely high rotational speeds without becoming unstable. A motor capable of spinning faster can potentially deliver more power from a smaller package, and that creates several advantages. The motor can potentially become lighter, occupy less space, and operate more efficiently, while reducing the amount of energy required from the battery. Tesla is also exploring similar motor concepts for future applications, including robotaxis. The objective is to achieve greater driving range while keeping the manufacturing cost under control. At the same time, Tesla is working to reduce its dependence on expensive rare earth materials, which could help protect the company from future supply problems and price fluctuations. This fits into a larger pattern in Tesla's engineering philosophy. The company rarely depends on one enormous technological breakthrough alone. Instead, it continuously looks for smaller improvements that can eventually produce a much bigger advantage. A technology may first appear in one vehicle, then be refined through real-world experience before eventually being introduced across a wider range of products. The ultimate objective is straightforward: build vehicles that consume less energy, perform better, cost less to manufacture, and can be produced on a massive scale. Because if Tesla eventually wants to manufacture millions of vehicles every year, relying permanently on expensive and difficult-to-source components could become a serious limitation. That is why the company continues developing many components internally while simultaneously improving its manufacturing processes. The goal is not simply to build an electric car that performs well today. It is to create a vehicle that remains economically practical to produce and operate for years to come. And this is where Tesla's new motor technology could become particularly important. Toyota, BYD, and other major automakers are watching developments in this area closely. The reason is obvious. If Tesla manages to produce a motor that delivers more power, uses fewer expensive materials, weighs less, and costs less to manufacture, competitors will face enormous pressure to respond. BYD has already built a reputation for producing affordable electric vehicles at scale. But if Tesla manages to combine lower costs with a significant improvement in motor technology, the competition could become even more intense. And other automakers have the same challenge. They also want to reduce manufacturing costs, improve efficiency, and become less dependent on expensive components and vulnerable supply chains. That is why Tesla's next motor could have implications far beyond Tesla itself. A technology that looks revolutionary today could eventually become an ordinary feature inside millions of everyday electric vehicles. But now we reach the most important question of all. What exactly is different about Tesla's new electric motor? And why could this seemingly small engineering change have such a big impact on the future of electric vehicles? So, what is actually different about Tesla's latest electric motor? And why has it created so much discussion across the EV industry? From the outside, an electric motor may not look particularly complicated. In fact, many motors can appear almost identical when you simply look at them from the outside. But the real story is hidden inside. The design of the components, the materials being used, the way electricity flows through the system, and even the software controlling the motor can make a huge difference. These details determine how efficiently the motor uses electricity, how much heat it produces, how much power it can deliver, and how consistently it can perform over time. One of Tesla's main goals is to get more work out of the motor while keeping the overall system as simple as possible. A system with fewer components can potentially be easier to manufacture, easier to assemble, and less complicated to maintain. But Tesla's approach goes beyond the motor itself. The company looks at the motor, inverter, and software controls as parts of one complete system. Instead of improving one component in isolation, Tesla can optimize the entire drive unit so that all of these parts work together more efficiently. And that matters because even a highly efficient motor cannot deliver its full potential if the electronics and software controlling it are wasting energy. Now, there is another important part of the story: permanent magnet motors. These motors are widely used in modern electric vehicles because they can produce strong torque while delivering excellent efficiency. But there is a trade-off. Many permanent magnet motors depend on rare earth materials to create the powerful magnetic fields they need, and this has become a major concern for the automotive industry. The supply of these materials is concentrated in a limited number of regions, which means manufacturers can potentially face higher costs or supply disruptions. Tesla has previously indicated that reducing its dependence on rare earth materials is an important part of its long-term engineering strategy. If automakers can achieve similar performance while using fewer rare earth materials, or eventually eliminate their use in certain applications, it could make the supply chain more resilient and potentially reduce manufacturing risks. But how does all of this actually improve efficiency? The basic principle is straightforward. The more of the battery's electrical energy that can ultimately be converted into useful motion at the wheels, the better. Every bit of energy lost as heat, electrical resistance, magnetic losses, or other inefficiencies reduces the amount of energy available for driving. That is why Tesla continues experimenting with motor windings, magnetic configurations, power electronics, materials, and software algorithms. Sometimes, no single change creates a dramatic improvement. Instead, several small improvements can work together and produce a noticeable difference in the final vehicle. Then there is another major engineering challenge: heat. When an electric motor operates at high speed or under heavy load for extended periods, its temperature can rise rapidly. And excessive heat is a problem. If temperatures become too high, the vehicle may have to reduce power output to protect the motor and other components. That means the motor might be capable of producing a certain level of performance, but it cannot necessarily maintain that output indefinitely. This is why advanced cooling and heat management systems are so important. Better cooling allows the motor to remain closer to its optimal operating temperature, potentially helping it maintain performance for longer while also improving long-term durability. But there is another direction engineers are increasingly taking. They are not simply trying to build larger and more powerful motors. Instead, they are trying to extract more performance from smaller and lighter units. And that can create a chain reaction of benefits. If the motor becomes smaller and lighter, the entire vehicle can potentially become lighter. A lighter vehicle requires less energy to accelerate and maintain movement. That can improve efficiency, increase driving range, and potentially reduce the amount of battery capacity needed. The space saved could also be used for other components, or simply allow engineers greater flexibility when designing the vehicle. However, making a motor smaller does not automatically make it better. Engineers have to find the right balance between power, efficiency, cooling, software control, durability, and manufacturing precision. That is why Tesla's latest motor is attracting attention as more than just a new mechanical component. The bigger story is the way Tesla is attempting to optimize the entire electric drive system.